Okay, now we're going to talk about another special case when we're factoring trinomials. And this is where we have a difference of two squares. You'll remember back when we did multiplying binomials, we found that if we had an a and a b, and one was being added and one was being subtracted, it always ended up being the first term squared minus the second term squared. Well, in this case, it actually helps us out because we can go and reverse the factor. In this case, it's not exactly a trinomial, it's a binomial. Okay, but it can help us factor these very easily. So let's take a look. We have x squared minus 64. And basically what this is saying is this is a perfect square, and this is a perfect square, so it must end up being in this format. So we need to have something plus something, and something minus something. Well, in this case, this is going to be x times x, so that's an x, and that's an x. And what times what is 64? Well, that's 8. Plus 8 and a minus 8. So this is what it would be factored out. We could do the same thing with the next one. It will always be plus something and then minus something. So p times p gives us p squared, and 7 times 7 gives us 49. You could still do the same thing even when you have a variable, or I'm sorry, a constant or coefficient on the first one squared, as long as it's a perfect square. So for example, 9g squared, okay, what times what gives us that? Well, that would be 3g. And 25. Well, 5 times 5 gives us 25. So it still follows the rule. Now finally, at the very end here, we have 10x squared minus 40. And you'll notice that neither one of those is perfect squares. Or are they? Don't forget to factor out a GCF before you get started. A 10 can be factored from both terms, leaving us with x squared minus 4. The x squared minus 4, that is a difference of two squares. So we can actually keep going and make this 10 times something plus something minus. Okay. X times x gives us x squared, and 2 times 2 gives us 4, leaving us with 10 times x plus 2 and x minus 2. It's the difference of two squares.